Okay, welcome back in our lecture sa physics. Lecture 5 pa rin tayo, and for this second part, we will talk about ang tinatawag nating conservation of momentum. So earlier, pinag-aralan natin ang momentum, which is defined as the product of the mass and the velocity of an object in motion, or not in motion. Kung if not in motion, then yung momentum niya is 0 kilograms meters per second. But in a system where objects collide or explodes, we do take note that the law states that the total momentum of a system is conserved. So that's what we call the conservation of momentum, which states that the total momentum of colliding bodies before impact is equal to their total momentum after impact. So technically, it's just the sum of the momentums of the individual bodies before is equal to the sum of the momentum of the individual bodies after. So before, so this is before, and this is after. Pangit na sunod. Anyways, so kung two-body system, which is we will usually use the sum of the momentum of object 1 before plus the momentum of object 2 before is equal to the momentum of object 1 after plus the momentum of object 2 after. And we do take note that these actually have another thing, is that the sum of the masses times the velocity, say v sub c, is equal to that 2. When we say big M, that is the total sum of the masses, and the v sub c is what we call the velocity of the center of mass. Magiging useful siya in times na binigay sa yung center of mass o yung velocity ng center of mass. So technically speaking, yung total momentum ng object is also the momentum of the center of mass. Okay, so let's deal with some problems. So for our fifth problem, a 1,400 kilogram cannon mounted on wheels fires a 60 kilogram ball in horizontal direction with a velocity of 50 meters per second. Assuming the cannon can move freely, what will be its recoil velocity? So, ang situation natin, meron tayong cannon like this. And meron siyang ball. Ang nangyari daw, nung nag-explode siya o nag-fire siya, yung cannonball nag-move with a velocity of 50 meters per second. Because of that, because of the momentum of that, nag-recoil rin ang cannon mo, which has a velocity of v sub c, directed to the other side. C means cannon na. So we are finding v sub c. So ang una natin gagawin is to determine the variables. So meron tayong mass of the cannon, which is 1,400 kilogram. Meron tayong mass ng cannonball, which is 60 kilogram. We're finding the initial velocities. So technically speaking, before launch, no velocity sila. So yung u sub c and u sub b are both equal to 0 meters per second. Ngayon, yung final velocity naman ng ball mo, that is directed sa, remember, yung direction, yung sign convention, positive and negative side. Since directed siya sa right, dito sa figure natin, that is 50 meters per second. And we're finding the recoil velocity of the cannon. what to do. So remember the conservation of momentum, which states that the total momentum of system before is equal to the total momentum after. So that is m sub c, u sub c, plus m sub b, u sub b. This is the before condition, is equal to m sub c, v sub c, plus m sub b, v sub b. This is the final condition. So we do note that u sub c and u sub b are both 0. So technically speaking, ang total momentum niyan is 0 kilograms meters per second. So that's it. So 0 equals m sub c, v sub c, plus m sub b, v sub b. We're finding v sub c. So what we need to do is you do some algebraic manipulation. That's gonna be m sub negative m sub c, v sub c equals m sub b, v sub b. And since natin ng v sub c, we're gonna divide both sides by negative m sub b to get our v sub c. M sub c pala yung divide, sorry. So cancel to cancel to, we have v sub c. So substitute the values. That's what's the mass of the ball? That's 60 kilograms. And what's the velocity of the ball? That is 50 meters per second, divided by the negative of what's the mass of the cannon? That's 1400 kilograms. Magka-cancel ang kilograms. So your velocity of the cannon is equal to negative 2.14 meters per second. So that's our answer for this problem. So we do note that the negative implies that the velocity or the cannon, when it moves, goes to the left side. Okay? So papunta siya sa left side at a speed of 2.14 meters per second. Okay. Now let's proceed to the next problem. For problem 6, a bullet of mass 10 grams strikes a ballistic pendulum of mass 2 kilograms. The center of mass of the pendulum rises a vertical distance of 12 centimeters. Assuming that the bullet remains embedded in the pendulum, calculate the bullet's initial speed. So, meron daw tayo tinatawag na pendulum. So, ano ang pendulum? It is this na may bob. Wala namang sinabing ano, no? Anyways. So, yan daw, initially at rest siya. Ito na center of mass of pendulum. Tapos, may bullet na pumunta dyan. Meron siyang velocity na, since nanap natin yan, let's say that's u. U not ano, joke lang. It's u going to the pendulum. Meron siyang mass na m sub b. Ito meron siyang mass na m sub p. Once na nag-embed na siya, that will be the next condition. This will move. So ito yung initial condition. Ito yung pendulum, tapos ito yung bullet naka-embed. Meron siyang initial velocity that we will call v. And this system will move upwards until its velocity is 0 meters per second. And because of that, nagkaroon ng height na displacement, which is indicated by 12 centimeters. Let's convert it into meters because naka-meters per second ang ating speed. That will be 0.12 meters. We are finding the u. So before that, alamin muna natin yung v. Ito yung nahanap natin yung v. Okay. To find V, remember meron tayong height, displacement. Tapos at that point, 0 ang kanyang velocity. So, technically speaking, yung energy, yung kinetic energy below here is converted to potential energy here. And remember sa last discussion, lecture number 4, we know that the kinetic energy is equal to the potential energy by the conservation of energy, the law of conservation of energy. So to find V, we'll just use this fact. So kinetic energy daw neto, that is, dito tayo magsulat sa taas, that is 1/2 the mass of that body, the yung embedded na bullet plus yung pendulum, times the velocity squared is equal to, ano yung potential energy? That is the mass of that C, center of mass, times gravitational acceleration times the height. So itong height natin. Magka-cancel to and you will get the V equals 2 times G times H. Yan. So, naka-square root So, substitute the values. We have 2 times, ano yung G natin? That's 9.8 meters per square seconds times, ano yung height natin? That is 0.12 meters. Ayan. Then, take its square root. You'll get V equals, ano yung V? That is 1.53 meters per second. So, yan pa lang, una pa lang. First part pa lang yan. Ngayon, ulitin natin. So, initially, meron tayong bullet dito with some velocity u. Ang mass niya is, ano yung mass niya? That is 10 grams. Gawin natin kilograms, that is 0.01 kilograms. Itong pendulum naman, meron siyang mass na 2 kilograms. After implanting, nag-collide sila in an inelastic collision, which is mamaya sasabihin ko or didiscuss natin later on. Pero nag-embed yung bullet and meron na silang velocity V, which we computed as 1.53 meters per second. That is after the collision. So, to find U, gagamitin natin ulit yung conservation of momentum equation, which states that the momentum of the bullet, the mass of the bullet times its initial velocity plus the mass of the pendulum times its initial velocity is equal to the mass of the bullet plus the mass of the, okay, dito na natin gagamitin yung center of mass. So the total mass of the bullet plus the mass of the pendulum, yan quantity na yan, times the final velocity of the collision. Yan na. Yan yung sinasabi kong center of mass. So ito yung center of mass natin and nag-move siya in 1.53 meters per second. So technically, the center of mass is the total mass of the system. Tapos yung velocity niya is etong V. So initially, this is the initial condition. Ang pendulum mo has a velocity of 0. So cancel na yan. We're finding U sub B. So that's gonna be U sub B equals etong right-hand side equation. So that's M sub B plus M sub P times the velocity divided by, ano to? Ito yung M sub B. Remember, dinivide natin para mag-cancel to. Ngayon, this is our equation for our U. So let's solve for U. That's 0.01 kilograms plus 2 kilograms times ang velocity natin that is 1.53 meters per second. And you're gonna divide that whole equation, that whole expression by the mass of the bullet, which is again 0.01 kilograms. And compute for that, then your initial bullet velocity is 308 meters per second. So that's our answer for problem number 6. Okay, recall natin. So, ang ginawa dito, dun sa after collision is nagkaroon ng kinetic energy yung center of mass na nag-raise siya. Since that kinetic energy is converted to potential energy, we use the conservation of energy equation to find the initial velocity of that condition, which is the final velocity of the collision. To find the initial velocity of the bullet, we use the conservation of momentum, and we got the initial velocity of 308 meters per second. Ayan. So, yun yung process natin. For the next problem, that is problem number 7, two identical masses collide and went in different direction as presented in the diagram. Determine the final velocity of each. So, this mass, M sub 1, pumunta siya, tinamaan niya itong M sub 2, and they separated to velocities V sub 1 and V sub 2. Excuse me. Okay. So, paano natin hanapin ang final velocity of each? So, again, this is M sub 1, this is M sub 2, this is V sub 1, and V sub 2. To find the final velocities, we do take note that in each axis, ang conservation of sorry. Ang momentum at the x-axis is conserved. Ang momentum at the y-axis is conserved. Okay. So, ang gawin muna natin is mag-sign convention. Gagawin natin positive yung right-hand side, negative yung left-hand side. Positive yung up, then negative yung down. Ngayon, let's separate these into two components. We find the momentum, the sum of the momentum at the x-axis first. So, the sum of the momentum is your M sub 1 times U sub 1 plus at x-axis to M sub 2 U sub 2 at the x-axis is equal to M sub 1 V sub 1 at the x-axis plus M sub 2 V sub 2 at the x-axis. Ayan. So, nagets yung process. We're taking first the total momentum at the x-axis. Okay. So, batay dito, meron tayong initial velocity dun sa mass sub 1. However, yung velocity ng M sub 2, wala sa x-axis. So, cancel natin yan. It's gonna be 0. And we do take note ulit that the masses are identical. So, we're gonna cancel all mass terms. So, matitira na lang natin is U sub 1 sub x equals V sub 1 sub x plus V sub 2 sub x. Okay. Ngayon, we have V sub 1 sub x and V sub 2 sub x. So, meron tayong vector V sub 1. Ito yung V sub 1 sub x niya. Diba? Ito naman yung V sub 1 sub y. Paano hanapin ang V sub 1 sub x? Gagamit tayong trigonometry. This is our angle 27 degrees. And to find V sub 1 sub x, that is equal to V sub 1. Since adjacent siya, that is cosine of the angle 27 degrees. So, isa-substitute natin yan sa V sub 1 sub x. That is V sub 1 cosine 27 degrees. Ngayon naman, meron tayong V sub 2. So this is V sub 2. And meron rin siyang components V sub 1, V sub 2 sub X, and V sub 2 sub Y. Angle niya is 50 degrees. So to find that is also, so V sub 2 sub X is also V sub 2 times adjacent ulit ang X, that is cosine 50 degrees. So V sub 2 cosine 50 degrees. Then ano yung U sub 1 natin? U sub 1 sub X, that is 12. Okay, this is for our equation 1. So, next, i-analyze naman natin yung momentum at the y-axis. So, that is m sub 1 times u sub 1 sub y plus m sub 2 times u sub 2 sub y equals m sub 1 v sub 1 sub y plus m sub 2 times v sub 2 sub y. Again, tingnan na natin yung initial conditions. Ang initial conditions natin papunta sa right si f sub 1. Meron ba siyang vertical displacement? Wala. So that is 0. Si y, si m sub 2, at rest siya. So wala siyang initial velocity, that's 0. So we have that. Ngayon, remember ulit na that masses are identical. So pwede na natin i-cancel yung m sub 1s. So our left hand side here is 0. And our right hand side is v sub 1 sub y plus v sub 2 sub y. So, refer ulit tayo dito para malaman natin in terms of v sub 1 and v sub 2. So, si v sub 1 sub y, set yung v sub 1 natin sa taas. Since pataas siya, that is positive, then, opposite yung v sub 1, di ba? Ay, v sub 1 sub y sa angle. So, that's gonna be v sub 1 times sine of 27 degrees. Okay. Para naman sa v sub 2 sub, this is v sub 2 sub y. This is v sub 1 sub y. For v sub 2 sub y, that is equal to, since pababa naman siya, that is negative times. Ano yung v sub 2? Then opposite yung vertical displacement, diba? So that is also sine 27 degrees. So that 0 equals v sub 1 sine 27, but to 27, minus v sub 2 sine, hindi siya 27, that's supposed to be 50 degrees. Basta 50 yan. 50 degrees. Ayan. So, ang gagawin natin is, we're gonna express this in terms of v sub 2. We're gonna find the expression for v sub 2. So, itatransform natin v sub 2, that is v sub 2 sine 50 equals v sub 1 sine 27. And we're going to divide both sides by sine 50 to get our equation for v sub 2. So that's v sub 2 equals v sub 1 sine 27 over sine 50. This is our second equation. So this second equation will be plugged in our first equation. So gamit na tayo ng bagong slide. So recall natin ang equation natin for yung first equation natin, that is 12 equals v sub 1 cos 27 plus v sub 2 cos 50. Okay. Meron tayong equation for v sub 2, di ba? That is v sub 1. Sulat natin dito, v sub 2 equals v sub 1 sine 27 over sine 50. Okay. We're gonna plug it in our v sub 2 here. That's gonna be 12 equals v sub 1 cosine of 27 plus, ano yung v sub 2 natin? That's v sub 1 sine of 27 over sine of 50 times ano yun? Cosine 50 degrees. Nagets? Okay. So, ang gagawin naman natin ngayon is if a factor out natin ang v sub 1. Since both term of v sub 1, we're gonna make it v sub 1 times, dito sa first term, that's just cosine 27 degrees plus, tingnan mo to ha, sine 27 times, tingnan mo, cosine 50 over sine 50. What is that? That is cotangent. That's cotangent 50 degrees. Or that's just the reciprocal of tangent. Para sa calculators yan. So, ngayon, we're gonna divide both sides by this bracketed equation, expression to get v sub 1. So that's v sub 1 equals 12 over, and then bracketed expression, that's cos 27 plus sine 27 plus times cotangent of 50 degrees. So when you solve it, when you input this in your calculator, you will get a value of 9.43 meters per second. So this is our answer for v sub 1. That's v sub 1. And this value of v sub 1 will be substituted here in our expression for v sub 2. So v sub 2 is equal to, ano v sub 1 natin? That's 9.43 meters per second times sine 27 degrees divided by sine of 50 degrees. And again, input mo lang yan sa calculator, you'll get a v sub 2 equals 5.59 meters per second. So this is our velocity or speed for v sub 2. And ito naman yung v sub 1. So that's the answers for our third problem. And that is it for our second part of this lecture.